Claire, shall we turn it over to you to talk about the latest news in the solar flare world?
Sure. So I'm not sure how many of you would be aware of the fact that we've had some pretty exciting solar activity over the past few days. So under normal circumstances, any kind of a large solar flare is always eagerly received by the solar physics community. However, the activity that we've had at the beginning of this week and over the weekend has been the most solar activity that we've had since the last solar cycle. So this is completely unprecedented, and the whole solar physics, heliophysics community are drastically scrambling to try and write research papers on this immediately. So there's people who are right this minute working on this data because it is so exciting and completely unprecedented. All of these came completely out of the view, or out of the blue, I should say. So my plan was to share some resources with you and to give you kind of an idea of what it's like when we're trying to figure out what happened. When you hear, hey, there's been a solar flare, how we go about, figuring out that it's been a big one, or how impressive it is, or where it's located on the sun. So I'm going to share my screen. Let's hope this works. Okay, is that working?
Yes.
My kitten. Cute. Okay, so here we go. So these are, there was four giant flares, one after another, last week. So the X-class flares are the biggest classification, and so there's four classifications. There's five, A, B, C, M, and X, and each of these is 10 times bigger than the previous one. So the X-class is, 100,000 times bigger than an A-class flare. And we had four of these in rapid succession, which is completely unprecedented. We haven't had something like this since maybe 2004, so this was really exciting. So all of these flares happened right on the very edge of the sun. So these are four different events that happened one after another. I think there was roughly one per day. You got the edge of the sun here, and these are pictures taken with the Solar Dynamics Observatory. So you can see just how really, really clear everything is, and how beautiful all of the pictures are. Let me try and minimize this. And so you can, get right in here and look at the detail of what's happening. So this big bright flash here, it was the flare, and so you can see they happen at the same site every single time. And so you can just about make out in this picture that it has kind of this pointy shape, which is the sign of a really energetic flare. So this was really exciting when we started to see this happen. So just for the record, I've minimized my chat window. So if other people see questions coming through on the chat window, feel free to interrupt me because I just can't see it right now. So these were our four flares. You can start to see these lovely post-arcade flare loops, this big long arcade here, which is a sign of a large solar flare as well. So these were some of the first pictures. So let me go to this site here. So this is a site called Solar Monitor, and it's the go-to site for most people in solar physics. It's not the prettiest of web pages, but if you're interested in solar activity, I recommend that you get yourself familiar with this because it's just a wealth of information. It's so helpful. There's four primary pages. There's this one here that says main. Then we have far side right here. We have SDO shortwave and SDO long wave. And basically all different kinds of views of the sun, every view that you can possibly expect you can get on this one web page. And you can do all kinds of zooming in. So you can zoom in here, you can decide, so this was the active region that gave us all those crazy solar flares last week. I can click on it, it will zoom in, it will show me this is the magnetic field. I can decide to look at the corona, it will tell me what it looks like. I can change my dates, I can go back a few days. And so this is a really helpful tool if you want to get some context for what was going on if there was high solar activity. But to find out exactly when the activity was, can everybody see this goes button on the right-hand side of the page? Mm-hmm. Am I going too fast, or is this doing okay? Okay, I'm going to take that as we're doing okay. So if we click on X-rays, this tells us X-rays that we see coming from the sun. So it's really just a line plot. It's just what we call a light curve. It just takes all of the emission from the sun in X-rays. It counts them all together and gives one total number. And so when the sun is quiet, we usually end up with this. We just look at the red one for the most part. The blue one you can ignore for right now. For the most part, it's usually pretty quiet and flat like it is here on the right-hand side. It is flat. But if I go back a week to when we had all these solar flares, you can see these huge big spikes. Can everybody see these spikes?
Yeah.
And so these are the solar flares that we were looking at. These are the 4 really big solar flares. And so there's a couple of signatures that we look for. So first of all, see the way it's this almost vertical line to begin with. It goes straight up to begin with, and then it has this more gradual sort of decay. So we call this the impulsive phase because it's an impulsive release of energy. Everything happens at the same time, and then we have a gradual decay back to normality. And we get another impulse, and then we get this other gradual decay. So these are the signs of some really exciting solar flares. And there's another really wonderful web page called The Sun Today that I can't recommend highly enough. It's a really helpful page. They have a Facebook page, so if you're a Facebook or you're a Twitter fan, you can sign up for their announcements. And to be honest with you, I actually get more information about solar flares, especially in real time, from my Facebook page than I do from anywhere else. Because somewhere in the world there's somebody watching the sun, and so if they see it released, they'll send a notification, and then it spreads like wildfire. Whereas if I had to keep an eye on this myself all the time, then that takes a much longer time it's a much more intensive time. So it's all about community and support. So
Claire?
Yeah?
Jim's wanting to know if there's a site to get proton flux from the sun.
Yes, so you can actually do that from this here. So on the right-hand side, you've got GOES, you got X-rays, and you can also do protons and electrons. So you can see this is already promising because we have this decay here, which means if we go back a few days that we should have had an increase, which we did. So you can see the red line, which is the 10 MeV protons, which are they're not super high energy, but you can see that there's a drastic increase in them. But on May 15th, you can see that there was also an increase in the higher energy protons, the 50 mega electron volt protons. So you can see them right here, and we can look at the electrons also at the same time and see if there was any change. So this is kind of a crazier plot to look at, but I just give you an idea of what we see. Let me go back to a quiet period so we get some comparison. So you can see the humps here. These are from the day length. So you're going from daytime to nighttime to daytime. But then as we go into the period with all of these solar flares, you can see that we start to get all of these huge changes and fluctuations as a result of the solar activity. So can everybody see that in the purple line and the yellow line?
Yeah, this is really amazing, Claire.
So it's a really wonderful webpage. There's all kinds of things that you can look at here. There's it will give you the list of all of the active regions that are on the sun at the moment. And it will tell you how complicated they are, although you need a bit of background knowledge to be able to understand the complication or the complexity of them. But what I really like is that if you go to the far side page, especially because the flares that we were looking at were happening right on the very edge of the sun, if we go to stereo B image, that's right here. Stereo B is, if we were looking at the sun, stereo B is on our left hand side at about 90 degrees to where we are. So this is essentially, if we are looking at this point right in the middle of the sun from stereo B, then the Earth is over here. So this is where SDO is, looking directly facing the sun here. So we have this perpendicular viewpoint. So that means that we can see whatever is going on here. And so all of these active regions, let me go back again to the high activity, all of these active regions that you see here, this is where, oh, we can't zoom in on that way. This is where all those solar flares were coming from at the time, this little blob right here. So it's just a great way of keeping context and, you know, really getting a full story of what's happening and making sure that we can, you know, fully understand what's going on. So let me real quick go back to here. So this is Actually, I have this in a set of stills that I will use instead.
Claire, while you're setting, Claire, is there a way to print out the images that you were showing us? Some people are having ideas about, so the kids can see the differences over time.
Oh, sure, yeah, you can, let me see if I go here. I think you can do this, and you can download PNG, which is just like a JPEG. It's just a standard picture file, and so you can just download the PNG file of various days and different wavelengths of a zoomed in area, whatever it is that you want to do. So you could certainly do that. You should, absolutely. So my recommendation is, if you're printing things out, to use the SDO data, because they tend to be very high quality data. So if we go, can I do this way? No. So you can see when we zoom in, you can see that they're nice, sharp pictures. I don't know if the internet is fast enough to be able to pick up this, but
I'm seeing it. I'm seeing it as you're showing it. That's pretty cool, Claire.
Okay, so the last thing that I wanted to talk about today is, of course, the effects on the Earth, and the Geons teachers will have an idea about some of this. So this picture right here is kind of complex. I want you to forget about the two pictures on the right-hand side, and I just want you to look at the circular one on the left-hand side. So right in the very middle, we have a white circle, which is the sun. And then we have circles and squares all around, and the circles represent planets and the squares represent different spacecraft. So you can see on the very, very top, we have a little legend here: Earth, Mars, Mercury, Venus, so on and so on. So the Earth is over here on the right-hand side. It's this little yellow one here. And then we have these different colors in a spiral coming out of the sun. And the reason that this is in a spiral, this is a very famous spiral called the Parker spiral. And this is the way the corona, the plasma from the sun, comes out through space. So it doesn't come out in a straight line, it comes out in a spiral. And if the easiest way I think about this is that if you have a pot of paint and you stir the paint in a circle, that you're kind of going to drag paint behind you, and the same kind of thing happens with the sun. So all of these lines are as a result of the magnetic field from the sun, and they're all stuck inside of the sun. They're all trapped to the plasma of the sun here. So as the sun spins around, the magnetic field kind of gets dragged along behind it. And so that's why we end up with a spiral sort of feature here. And then the green parts here are just areas where we have different different densities of the plasma. So this is usually as a result of a coronal hole. So that means that there's probably a coronal hole somewhere on the front side of the sun that's providing this big burst of higher density material. However, what I want you to do is watch what happens now. So these are some of the CMEs that came from the solar flares of last week. So can you see the CME, as the CME moves out through the solar system, how it changes everything?
Wow. Oh,
wow. You can really see how it affects the solar system. This is from a model called ENLIL, and they make these for every coronal mass ejection that comes from the sun, whether it's Earth directed or not. So keep an eye again on where the Earth is right here, and we'll see what sort of effect the CME had on the Earth. And this will help understand why maybe we didn't get much aurora last week from this. So you can see that only the very edge of the CME actually interacts with the Earth right here. So if this was heading directly towards the Earth, then we should expect some really fabulous aurora at night, but because it was directed almost perpendicular, then we didn't see so much. So I have a different picture right here. So this is from the 19th of May, and you can see that there was another CME. So this CME right here that is directed directly at the Earth. So that means that on the 19th of May, there should have been some amount of aurora happening in the sky, because this is the CME. Unfortunately, I only have one picture of this event, and you can see that it's headed directly towards the Earth. So the Earth, we have the CME, and then Spitzer right here is just the name of a telescope. But it's the same kind of concept. So it's kind of a complicated picture, but it's also really helpful in understanding what you can expect, whether or not we're going to get northern lights, how intense they can be, and various other different kinds of effects. So it'll be really useful, especially for those of you with magnetometers, if you're not familiar with these. These could be a great help to predicting when you're going to get some activity. So I will leave you with this sort of a picture, and I think this is a good time to take some questions if you guys. Oh, sorry, that I have one more thing that I wanted to show you, and this actually was why I was late to the telecon, because I was trying to download this. So I'm going to copy this link into the chat box, and you guys can look yourself. I'll also play it here in the hopes that we can just play it straight up, and the browser will be fast enough to keep up with it. But you should definitely take a look at this in your own time also.
Also put it on the Wikio, Claire.
Okay. So this is a video of the Solar Dynamics Observatory, and we've got 3 different temperature here. So we've got the corona, we've got the higher corona, which is showing this sort of yellow-green stuff around the edge, and then we have the blue emission, which is the middle part of the corona, and then we have 304, which is the chromosphere, which is almost the surface. It's not quite the surface, but it's the next level up. And so this is the period of time over these series of really big flares. So just watch this region here in particular, but I'll play it a few times, and as you see it, watch for activity elsewhere. So we call this a thing called sympathetic flaring, where you have a big eruption on one side of the sun that triggers something on completely the other side. So let me know if this is playing effectively, and if we can just pause it and you guys can watch yourself. Those bright flashes are the solar flares. So it's playing kind of fast, so it might be helpful to download this and watch it in your own time. And I can try and make some other ones. So you can see there's a CME coming off here, there's another one happening here. I can make some other ones that are a bit slower also, so watch, and up here. And so the reason that we combine different colors here is as a result of the fact that we have different temperatures, and we use different temperatures all at the same time, because they tell us about different parts of the atmosphere. So for example, if we were looking at the chromosphere, which is the orangey color on the disk, then the orangey color tells us about the low down loops, but it won't tell us anything about the upper atmosphere. And likewise, the upper atmosphere is not going to tell us too much about what's happening close to the surface. So right over here, let me see if I can pause this. Let's see, there was a really nice. Oh, I know what I'll do. I'll play this on.
Did the Van Allen probes pick up a lot of signal from these ejections?
Not that
I
I'm
don't
aware
know.
of. This
Somebody.
is Dawn. Sorry, Claire. Not that I'm aware of, but while Claire was talking about it, I just wrote to 2 of the scientists and asked them that question, so I can post the answer on Wikio.
Okay.
I was thinking that probably not a whole lot, because it wasn't a direct hit, but it'd be interesting to see if there was something there.
Yeah.
So just to go back to this movie real quick, what's really interesting here, if you look on the upper left-hand side, which coincidentally on the sun, even though this is the west side of the Earth, this is actually called the east side of the sun, which takes a lot of getting used to as a new graduate student. I always got that confused. But take a look here, and what you'll see is there's like an eruption of material, and then following this, we get this really bright flash of the solar flare. Wow. They have this weird eruption, and it sort of collapses back down again. And then bam, we get our solar flare. So this is the first X-class flare that we see. And then we move on, and keep an eye on the right-hand side. On the bottom part of the sun right here, we're going to get a coronal mass ejection. We get a little filament liftoff. But at the same time, we have this the post-flare arcade forming right here. And then a couple of hours later, we get, here we go, bam, another solar flare, which triggers a coronal mass ejection on the completely other side of the sun. You can see this filament eruption right here. And this is only covering the period of the first 3 out of the 4 solar flares. And then we've got the final solar flare of this series right here. And then you get this lovely, beautiful series of post-flare loops. So there you go. You guys are free to download this and have a look at it in your own time. And I'll try and upload it to the Widgeo also. And I'll try and make some more movies. Or if I find some more movies, I'll be sure to share them for you there.
And Claire, speaking of movies, Jim Bean put a link in the chat window to a YouTube video of a comet hitting the sun, producing a solar flare. So maybe we can add that to the Widgeo, and then you can take a look at it and see. His question is it possible?
Okay, let me just see.
So we're getting a little short on time here.
Okay.
So maybe that's something that you
we'll
could
do
follow
after.
up on afterwards.
Okay.
Yeah, that's what I was going to suggest, is that we do that at the end. But I am making a list of all these resources from the chat window, and I will post them on the Widgeo as well. So, and I have Jim's as well.
Okay.
And Claire, when you slowed down the video, that was really awesome. Then you could really see it.
Yeah. I made this earlier on, and I had it sped up because it was taking ages to run. But I realized that might actually have been more helpful for people, so I'll make it again. For anybody who is interested in making their own J Helio Viewer, I can't recommend it enough. It's an application that you can use, so go for it. Okay, that is me. So I'm happy to take any questions either on the chat or afterwards or on Widgeo or however you might like.
Tell us the name of that viewer that you used to make the movie.
It's called J Helio Viewer, and I'll just... Maybe this actually would be a useful thing, another meeting, to do a quick tutorial on J Helio Viewer, because it really is super helpful, and you can just make your own movies and you make them look however you like.
Yeah, that's interesting. I could imagine we could do a fairly lengthy tutorial on that.
Yeah.
Yeah, I think that would be really, I think that's something, as long as when you do that, Claire, you can show me how to use my 3D Sun app at the same time. I'm confounded by that one as well. So that was lovely and very informative. It's like, oh.
Well, let me do one quick last thing, and then I promise I'll give you back your meeting. So, here. Oh, okay, never mind. It won't let me do it. Everything is frozen. Oh, there we go. So this is J Helio Viewer. And so you can just play the movies. You make them look however you want. You just put your own dates in, and it just pops them right out for you. Okay, here you go. All right, so you know where to find me if you've got questions, and we should do a tutorial on J Helio Viewer.
No.